Okay, let's finish this problem. What we've done so far is to calculate the value of the critical value, the fence value I like to call it, the value of z that we'll use to determine whether we should accept the null hypothesis or whether we should reject the null hypothesis. And of course, if we reject the null hypothesis, there's nothing left but to accept the alternative hypothesis. So the z values, the critical values, the fence values that we're going to use range from 1.282 to 3.09. So 1.282 somewhere in here up to something greater than 3. And again, alpha is the probability of being wrong. What's the probability of making a type 1 error? Now, the value of alpha that you select depends on the circumstances. If, let's say this is an advertising campaign and you want to publicize to the public that, hey, our customers are very satisfied. Well, in advertising, a 95% level of confidence or an alpha value of 0.05 is appropriate. If this is a life or death situation where being wrong is just going to cause zillions of dollars or cause a patient to lose his or her life, then we better be 99.9% certain. But if it's also just something that we're casually interested in knowing whether we're right or wrong, 10% is good enough. And of course, the value of alpha determines whether we need to take a large sample or not. But what we're looking at here is a range of values from 1.282 up to 3.09. Well, let's move on then and ask ourselves, what does the sample data really tell us? And we're told in this particular problem, move it in here, that the x bar, the sample mean, the average value of the sample of 65 customers we sampled was 42.954. Now that's good news because, hey, 42.9 is greater than 42, but how much bigger is it really? Well, to answer that question, we need to know what the standard deviation is. Now, we don't know what the population standard deviation is, but we do know the sample standard deviation of 2.64. And we can use the formula for z to calculate the number of standard deviations to 42.954 is compared to the assumed mean of 42. How many standard deviations to the right of 42 is 42.954? Well, here's the formula. We take the 42.954, our x bar value, I should say x bar, shouldn't it, and subtract from it 42, the assumed mean, and divide that by the standard deviation. Now, it's not just the sample standard deviation, of course. It's the sampling standard deviation, the standard deviation of the sampling mean. And to get that, we take our sample standard deviation and divide by the square root of n. I've done that, of course, and the answer is 2.913. All right, well, now we can use this to do our analysis. We're almost there. I think you can see that 2.913 is way out here. It's almost but not quite 3. So we know that this area under the curve is going to be pretty small. And in fact, comparing it to our critical values, we see that it is greater than the 0.01 alpha, the 1% alpha, but slightly less than the 0.1% alpha, the 0.001 alpha. So we can be very confident that our advertising claim is true because 2.913 causes us to reject the null hypothesis that people are not, that the average satisfaction level is 42 or greater. 42 or less, we reject that null hypothesis and accept the alternative hypothesis that the mean must be greater than 42. Put another way, it's just simply impossible to believe that we would have drawn a sample of 42.954 if the true mean is 42. It's really got to be something greater than that to believe that we could get that kind of average value in a sample. Okay, we're almost done, but really we need to try this a little more formally, state this a little more formally. So here's what I've done, and I want to show off my Excel here a little bit. Saying the same thing I just said in words. This formula says if E47, which is the test statistic, is greater than C53, which is the critical value, then we reject H0, otherwise we accept H0. And I can use that formula, just pull it across, and Excel automatically tells me the solution. But I can do that with my eyeball just as well as not. So what's the practical real-world implication of all this? Well, what do we tell the boss is the real question. And in this particular case, we can say, boss, we can be 99% confident that our customers are very happy. Well, the boss says, hey, that's great, but what does it take to be 99.9% confident? Well, with the data we have, boss, we can't be that confident. We can only be 99% confident. And if we want to be more confident, we probably need to take a bigger sample. 65 gave us a standard deviation that is simply too large to make that conclusion. Okay, now the question is it worth the money to go out and make that, to do that extra sampling to get a better feel for how confident we can be? Another way of looking at this, though, is the p-value approach. Again, it's exactly the same approach that using the exact same numbers, the exact same concepts, just doing it a little different way. Rather than, what we're going to do is take the 2.913z value, and rather than comparing it to a critical value, we're going to say, what are the odds? What's the chance of getting a sample of mean 42.954 if the true mean is 42? Well, rather than, what we do is use the normal standard distribution, of course. And I should do it two ways. I'll do it, first of all, without subtracting for 1. It says that we can be 99.82% confident. So that's almost 99.9, Boston, but not quite. Put another way, this is equal to 1 minus 99.82, or an alpha, or critical value of 0.0018. There's a 0.18% chance that we're wrong. Again, same conclusion, just looking at it a little different way. Okay, I hope that helps. Again, the only way I know how to learn this concept, these concepts, is to do some problems. And of course, I've given you some for this week, and we'll do it again next week. And in fact, the week after that is review week, so we'll have another run at it for a total of 3 weeks. Hopefully by that time it'll start to sink in, and this will become a little more like second nature to you. But again, the concepts in Chapter 7 and 8 are being used here just in a different way. There's nothing really new. Okay, ask questions. I'm sure you'll have them, and I'll look forward to seeing you online.